Good evening, everybody, and welcome to the last presentation before the party. So, little background. My name is Trombetti. I'm a technology entrepreneur. I've been working in language translation for the last 20 years, and for the last 3, I started to become a venture capitalist, investing in about 30 startups, mostly in AI. So what I'm doing today is I'm presenting you a research project that I've been coordinating and that I felt in love with, and it's just to become a startup. We'll talk about how we use a new approach in machine learning to tackle machine translation. So before starting with what we do, let's say in a few words what is actually happening right now. So how people are doing machine translation right now. I mean, Google Translate, Microsoft, Bing, how do they work? We basically look for very large corpora, sentence level, billions of words, and we use machine learning, both statistical or deep learning approaches, sequence to sequence, in order to extract and learn how to translate a certain sequence of words into another one. These approaches takes from weeks in statistical to many months on a single GPU for deep learning. So these are huge models, cost a lot of money, and are actually also very complex to deploy. They're very block solid. You do it once in training, and they're done. So by working in this industry for 20 years, my company, the first I founded, Translated, has worked with about 200,000 professional translators. And we're sending them machine translation as a suggestion for them to deliver the final quality. They edit and they change what is wrong. While doing this, we had this unique opportunity of observing what is not working today. And we learned these 2 things. The first one, that machine translation today does not adapt to context. If you're translating a legal document, finance, or specific terminology for your customer, and a single sentence will be translated always in the same way. This is mainly due to how we do the training. We just have a bunch of sentences, random order. We even lose the proximity of sentences. We lose every information about context in documents. So each sentence gets translated always in the same way, doesn't matter the context. The second thing, and it's very, very frustrating for translators, is that machine translation today does not learn. These big models that takes months to train are static. So if a professional translator will fix one error in one document, it will have to fix the same error again and again for the rest of the following days that it's working on the project. This is extremely frustrating, and it's actually making the translator lose the confidence with machine translation. So, by observing that, we realized that actually the big problem is this initial big training. Can we invent a way to do machine learning for machine translation without having a large initial training? And yes, we think it's possible by not training but indexing. So what we're doing is creating a data structure that takes all these billions of words and index them into a database in a way that if I have to translate a sentence, the house is red, in milliseconds I can retrieve the 1,000 sentences that are similar to that sentence with its corresponding translation. And what I can do, I do a runtime machine learning, a translation time, only on the subset of information that I actually need to deliver that specific sentence. By doing that, I'm solving the first problem. Being a database, and being just indexing, I can add information on the fly as much as I want. So an algorithm that before was not incremental, now is incremental. The second opportunity that comes with this model is that I can attach a metadata to the source of information. So now I don't have to bunch all this data together. I can actually say, okay, this data is coming from customer A. This data is coming from the United Nations corpus, and this data from the European Parliament. And this is about information technology, and this is legal. Just IDs to any documents to identify the source they're coming from. Once I do that, and once we are translating a document, I can take the entire document to calculate context similarity with all the domains I have, the topics. I can then calculate the score, and so when I do this before, when I take the 1,000 sentences, I can actually take 1,000 sentences, the first 100, wherever I can find, from the context that best match my document. So if I'm translating legal, I will fetch more information from anything that looks like legal, and then something that is more similar. So I'm solving the second problem, context. And actually, for each document, in real time, I'm doing the machine learning only on the piece of information that is more relevant to translate that piece of sentence. So it's a nice idea, we implemented it, and is it working? So what we did is basically compare the results of this technology against Google Translate for generic text. So not in a specified vertical, but just taking 400 million words of generic text, indexing the information, just keeping as an information the source. So if we are collecting the data from the Oracle website, as a metadata, we're just saying oracle.com. We overperformed at Google Translate in all the language pairs that we've been testing. We did also test against Microsoft Translator App, which is the premium version of Microsoft Bing for the enterprises, and actually overperformed over on that. We applied this algorithm to statistical algorithm. And we're now working to apply the same idea of context learning and incremental to deep neural network. This is critically a much bigger challenge because they're not designed to do that. And delivering translation sub-second in that could be problematic. But it's the challenges that we're facing right now, we're working on. So the team is coordinated by my company, Translated, FBK in Trenton Research Center, University of Edinburgh. These two are actually the main contributors to the current state of the art, which is called statistical machine translation and neural machine translation, and TAUS, which is an industry association that is helping us collecting the data. So, can we generalize this approach of runtime machine learning to other verticals? We think that it's hard, but it's actually possible. In all cases where you have a strong need of incremental learning, and also the main difficulties is that you need a domain where a subset of your information contains all the information needed to learn how to do your translation or your machine learning task. So wherever there is a small subset that contains all the information, you can actually use the same approach. So in short, we think that language translation is one of the hardest tasks today in artificial intelligence. And we're doing a very hard work to try to solve it. If you want to help contribute, please come to meet me after. Thank you.